Today I want to talk about how the Earth's geologic timescale agrees with the fossil record. So we believe the Earth originated about 4.6 billion years ago. It was originally a large molten ball of magma. It was the rock and Earth were completely molten. And over time, the Earth eventually cooled. And from 4.6 to 4.1 billion years ago, the Earth was in a cooling process, and eventually it formed these rocks that we find up on the northeast coast of Hudson Bay in Canada. These are some of the oldest rocks on Earth. They're about 4.1 billion years, and we know that because we can use a technique called radioactive dating. Radioactive dating involves measuring the amount of radiation given off by a sample of rock and comparing that with an amount of radiation given off by a modern rock. And over time, the radiation will decrease. So by knowing how much radiation these rocks give off, we can calculate how old they are. So we believe these rocks to be about 4.1 billion years. Radioactive dating is also called absolute dating because it gives you an actual age. Relative dating, when we look at the layers of the Earth, only tells you when one thing happened before another. Absolute dating tells you the age of something. So the rocks came first. This right here this is fossils of microbes. They're actually mats of billions and billions of microbial cells. And those rocks are formed by the cells hardening over time, and it leaves a record of those cells. And if we look at a small sample of these microbial mats under a microscope, we can see cells like this. And these are the first living things. We call them prokaryotic cells because they don't have a nucleus. They're very, very simple and very, very small. They're like modern bacteria. We still have cells like these today. And when we use radioactive dating, we've determined that these prokaryotic cells are about 3.5 billion years old. Next, we find samples of cells that have a nucleus in them. These are eukaryotic cells. They have a nucleus. And if you look here, these rings are actually colonies of cells that were found in 2 billion year old banded iron formations buried in the state of Michigan. And we can date the banded iron, again using radioactive dating, to about 2.1 billion years ago. So we actually believe the first eukaryotic cells, or cells with a nucleus, arrived prior to 2.1 billion years ago. And then this fossil right here is our first tiny trace animal creature. This one's about 1,000 million years ago. So that is much, much younger in time. And you can see the outline of the critter in this fossil right here. And again, we can date this fossil and determine its age. And next up is a diagram we already looked at in the relative dating video, but it kind of shows as you move upward from the earliest organisms towards the modern organisms, relative dating helps put everything in an order. Invertebrates, jawless fish, jawed fish, amphibians, reptiles, dinosaurs, early mammals, modern mammals. And as we dig down, it tells us the order in which these creatures happened. We can also use radioactive dating to actually put dates to when these things may have arrived. For example, we know the KT extinction was about 68 million years ago because we can age the rocks that occur along this boundary between the dinosaurs and the age of mammals.